Next, let's use a thermistor to learn about the analogRead function, arithmetic operations, and the float data type. A thermistor is a type of temperature sensor that changes its resistance as the temperature changes. By utilizing this property, we can measure temperature by detecting changes in resistance. However, directly measuring resistance can be challenging, so it's common to create a circuit like this to convert the resistance into voltage, which can then be read. The detection resistor, RD, is a standard resistor that doesn't change with temperature. Assuming load has a fixed resistance, the voltage at point A will vary based on the resistance of RT. By measuring this voltage change, we can calculate the change in resistance, which can then be converted to temperature using a formula. The V constant represents the thermistor's characteristics, indicating the rate at which resistance changes with temperature. This value can usually be found in the thermistor's datasheet. This is the circuit we'll be building. When you touch the thermistor or heat it with a hairdryer, you should see the temperature change. Let's go ahead and build the circuit. The materials we'll be using are an Arduino Uno, a breadboard, 3 male-to-male jumper wires, a thermistor, and a 10k ohm resistor. Note that there are two types of thermistors, NTC, where resistance decreases with temperature, and PTC, where resistance increases with temperature. We'll be using an NTC thermistor, which is commonly used for temperature sensing, so be careful not to mix them up. Here is the circuit diagram. Arduino's analog input terminals have a 10-bit ADC analog-to-digital converter, which converts a voltage in the 0-5V range into a digital value between 0 and 1023. The voltage corresponding to each memory slot is called the resolution. In our case, we're dividing 5V into 1024 parts, so each step is approximately 5 MB. Arduino has 6 analog input terminals in total, and we'll be using the A0 terminal. Choosing the value of RD requires a bit of caution. If load is too small or too large, the voltage at point A won't change much, making it difficult to calculate the resistance accurately. In practice, you'll want to fine-tune RD based on the temperature range you want to measure, but for now, using a value close to the thermistor's resistance at room temperature should work well. In this case, since the thermistor's resistance is 10k ohms at room temperature, we're also using a 10k ohm resistor for RD. Next, let's build the circuit based on the breadboard diagram. Follow this diagram to set up the circuit. Now, the circuit is complete. Let's move on to coding. Open the Arduino IDE and click on New File under File. Enter the program shown here. Lines 5 to 8 define constants used to calculate resistance. We're using the float data type here because we're dealing with decimal points and division. For this lesson, we'll be using the serial monitor feature to observe the changes in values. This feature allows Arduino and your computer to communicate data via serial, enabling real-time monitoring. By using the serial.begin function inside the setup function, you can activate this feature. In the loop function, we're first reading the voltage using the analogRead function. Next, we calculate the current resistance. The formula is easier to understand when thought of in terms of ratios. Arduino can perform general arithmetic operations, such as addition, subtraction, multiplication, and division, as well as more complex calculations like logarithms and square roots. We then use the formula written here to find T, the temperature. This is a well-known formula for calculating thermistor temperature, so if you're interested in the background, check out this website. Note that at this stage, the unit is Kelvin, representing absolute temperature, so be careful. Finally, we convert it to Celsius and send the value to serial.println, completing the temperature reading. The wait time, or update frequency, can be any value, but for now, we've set it to 0.2 seconds. Once you've saved the file, press the Upload to Board button in the toolbar to write the program. After uploading is complete, press the Serial Monitor button in the top right corner. You should see the values updating every 0.2 seconds. To verify that your calculations are correct, measure the room temperature and check if the value roughly matches your expectations. That concludes this lesson. Try touching or heating the thermistor to confirm that the temperature changes. Once you've done that, move on to the next lesson. That's all for now.